Thank you, Tim. Thank you for being here on day 2, despite the weather and despite the pub yesterday night. Thank you for traveling from far abroad, US, Canada, Japan, and other countries. I'm doing this talk quite a lot at AWS event, conference, or AWS user group. And I usually spend a lot of time talking about Swift server-side and a bit less about serverless, because the folks that are working with AWS kind of know the serverless part. Here, given the name of the conference, I will do the opposite. I will spend no time on Swift and why Swift on the server side, but spend a bit more time on the serverless part. As Tim mentioned, I'm Sébastien Stormacq. It's difficult to pronounce, so people call me Seb. I'm from Belgium, and I'm working for AWS. So what is serverless? It's not this. Serverless means you don't have to manage the server. Someone else is managing the server for you. Maybe you have noticed I have some white hairs, but when I was younger, deploying software on the server means acquiring a server, putting it in a data center, connecting the network, patching, installing the operating system, configuring everything, then deploy your application. With serverless, someone else is taking care of that. Serverless is also about scale, so it can go from 0 if it is not used to a lot, or hopefully a lot, depending on the actual usage of your application. And a serverless system is built in for high availability, so you don't have to think about having to deploy to multiple data centers or multiple regions. Again, someone else is taking care for that. And the best part is that you only pay for what you use, so if you are not using it, you should not pay for it. Maybe except storage, because, hey, we cannot delete storage. We need to keep the storage in between invocation. But in a serverless system, for me, it's something that can scale down to 0 to a lot, and you only pay for the usage. On AWS, there is one service that will celebrate its 10th birthday, its 10th anniversary this year. It's called AWS Lambda. I was planning to do a couple of polls, but I cannot see anybody in the audience, so I will skip the polls and go straight to Lambda. So Lambda, it's a compute service. It allows you to deploy code on a serverless system. As a developer, you just write your code, deploy your code, and AWS takes care of everything else. So deploying, maintaining the runtime, maintaining the availability, the connectivity, the protection against DDoS, all these things, you don't need to think about it. You just write your code and deploy it. And by default, Lambda can support Python, TypeScript, Go, Ruby, Java, C#, and all the ones that are mentioned there. You will notice that Swift is not there, and I'll come to that in a minute. Lambda by itself, it's not alone, because it's a function. You need something to call that function. And of course, there is an API to call that function, but it's not very practical to call that API. It's not standard. So most of the customers are exposing their Lambda function through an API. It might be a REST API with a managed API gateway, which is also serverless, so you don't have to install anything. You just configure the gateway, and the gateway will provide your application an HTTPS endpoint with a valid certificate, load balancing, and will invoke your Lambda function when a client application is calling the REST API. Might be a GraphQL API, it might be maybe a message arriving on a queue will trigger a Lambda function to consume that message. It might be a file arriving on S3, it might be a change in a database, like a trigger in the old days of a relational database. You have a NoSQL serverless database, a change happens, and a Lambda function is being triggered. You can trigger functions on a schedule as well, like every morning, 7 a.m., you trigger your Lambda function. So if you never saw a Lambda function, let me quickly, very briefly show you how to create one. The most easy way is to start with the AWS console. You go to the Lambda part, create a new function. You choose a name, you choose your runtime from the managed one, the one AWS does provide. So in this example, I choose Python running on ARM64. I can even type the code directly there for non-compiled language, and I click deploy. The code is super simple. It's one function that takes 2 parameters, the event, so that's the payload received from the caller. It might be an API gateway, GraphQL, SQS, S3, so it's a payload, and a context that gives a bit of details about the environment where your code is running, and then you return something. Pretty basic. You have monitoring built in, like number of invocation, errors, and things like that. Okay, enough about Lambda. Oh no, one more thing. How do you deploy a Lambda function? Imagine that you have written your code on your laptop, you have a zip file with your code or something. You can deploy through the console. That's what we call IAC, infrastructure as click. It works, but it's not very repeatable, it's not scalable, so it's better to write code to deploy your Lambda function. One very basic way to do so is to use the CLI. You type AWS Lambda, create functions, bunch of parameters, and it creates your Lambda function. This doesn't scale well neither, so it's better to write IAC, infrastructure as code, and there are different ways to do that on AWS. Maybe you heard about something called CloudFormation, maybe you heard about something called CDK, Cloud Development Kits. But for today's presentation, and in the context of Swift and Swift on Lambda, I would like to introduce you Sam. So Sam, this is the audience, this is Sam. Sam, it's serverless application model. So with Sam, you describe your infrastructure as a YAML file. And then you use a command line to actually create the infrastructure for you. So if we zoom on this a bit, you see that I have a list of resources. I give my resource a name, HTTP API Lambda. I say it's a function, a couple of properties, and a link to the zip file that contains my code. I can pass environment variable and things like that. In the second part of the file, I define what will call that Lambda function. What is the way to invoke that Lambda function? In this case, it's an HTTP API with the get HTTP method and the pass/test. So with this very simple template, I use the SAM command line, SAM deploy, and it will generate the infrastructure for me. And that's repeatable because I can deploy to multiple regions, to multiple environments like development, test, production, and things like that. One of the questions I frequently receive is, okay, it's great, you said that it's scaled to 0, but how much does it cost? And actually, it doesn't cost a lot. It's almost free for development and test. And depending on your usage, it might cost more. So there are two pricing metrics. The first one, it's for every millisecond of CPU time. And I will not read the number, but it's 0.0000 something US dollar without tax for every millisecond on an ARM environment. And then there is a cost per request every time you invoke the function, and that's 20 cents for every millions of requests. But the best part is the last line. There is a free tier, so every month you get 1 million requests for free and 400,000 seconds of CPU for free. So basically it means you can run small application for free, you can certainly develop and test for free, and you only start paying when you invoke the function a lot or when the function consumes a lot of CPU, runs for a long period of time. And that's the end of the first part of this talk, just a gentle introduction to Lambda. Now let's go to Swift and Swift on Lambda. So, what about your existing app? Since yesterday we talked a lot about Vapor, Hummingbird, or maybe other web app. Can you deploy a web application on Lambda? And the answer is yes, but if you remind the model I presented, so on one side you have Lambda, that's the compute. On the other side you have the API gateway, which is the HTTPS endpoint, and you have something, a client application calling the HTTPS endpoint. But a web app typically has its own web server, so it has its own endpoint. So how do we fit that together? To understand how we can fit that together, we have to zoom a little bit inside Lambda. So how does Lambda run? Lambda runs on virtual machines, EC2, in the vocabulary of AWS. And inside these virtual machines, we have a micro VM running on hardware. So inside the micro VM, we have the Lambda runtime engine that is provided by AWS in most cases, that will pull even from the Lambda service. So if the API gateway calls the Lambda service, the runtime engines in the micro VM will actually pull the event and invoke your code. Remember my Python example, so call the Python code, for example. So where do I fit the HTTP server in that scenario? How do I put a Vapor app or a Hummingbird app into that? How can I tell the runtime engine to actually make a call to an HTTP service and not calling a specific function, a specific entry point? And the other question is, what will provide the HTTP endpoint? Because obviously, if I deploy a Vapor or Hummingbird application inside Lambda, it will not be exposed. I mean, the HTTP server from Vapor or from Hummingbird will not be exposed to the external world. So I know that in Vapor and Hummingbird, there is a Lambda adapter, so you can use these native libraries to integrate them into Lambda, but I want to show you something else, something which is a bit more generic that works with any type of web application, including if you have an Express Node.js application or Python Flask application or a Java application, you can deploy that as is in Lambda without changing anything. So how does it work? We need 2, 3, 4 components. The first one is an HTTP endpoint. Let's reuse the API gateway I talked already before. The second one, you need something to convert the Lambda code invocation to an HTTP invocation to leverage the existing HTTP server inside your web application. And for that, we use a mechanism called a Lambda extension. So a Lambda extension is a standard part of Lambda that can intercept a request, transform the request, and deliver it to your code, your solution running inside the micro VM. And it can intercept the response as well, and transform it, and send it back. It's like a middleware inside the micro VM. So the idea would be to write a Lambda extension that takes the Lambda parameter as received from the API gateway and recreate an HTTP call on localhost 127.0.0.1 to invoke the web application and to leverage the routing inside that web application. Then take the response from the HTTP call, repackage that as a Lambda response, and give that back to the API gateway. So yes, there is a performance cost of doing that. It's not a perfect solution, but what I like in that solution is that there is absolutely 0 line of code change required to change in your application. You can take the application as is and deploy it to the Lambda function. To package everything together, we use Docker containers, and of course, to deploy everything, Sam is my friend. So how does it work? You take your existing application, you containerize it, so you create a Docker file to host it, and you add just one line to your Docker file. And that line is the line that includes the Lambda layer, and we have a Lambda layer that does exactly what I described. It's called the AWS Lambda adapter. You package the two together, you write a SAM template to describe what you want to deploy to Lambda, and SAM will create for you the API gateway, the Lambda. It will deploy your code inside the Lambda micro VM, and it will create the Lambda adapter for you. So let's see how it works. Imagine I did that. I can just type SAM build and SAM deploy. It will actually build the code, so it's a very simple Vapor app, and deploy. I accelerate the video a bit, as you might have noticed, because I don't want to wait for the full build to happen. It creates the Docker image, and it deploys everything. At the end of the deployment, it gives me the endpoint, so the URL of the API gateway, and I can test that URL. So I just copy the URL, take a browser, and paste it. It's a very simple application that echoes back all the HTTP header I receive. So the response is made of all the HTTP headers that I receive. Good. Just one line has been added to a Docker file. The Vapor app or the Hummingbird app is unmodified. So the Lambda Web Adapter, it's an open source project from AWS that allows you to deploy any kind of web application inside a Lambda function. And why would you do that? To lower your cost. Remember, if you are not invoking your Lambda function, you're not paying for it. And it's the same on the API gateway. So it's for small usage application for development and test, is much cheaper than running a permanent virtual machines or Kubernetes cluster or something like that. Are you still with me? Yes. Okay. So maybe we can write Lambda function in Swift as well. And for that, I need to introduce the AWS Lambda custom runtime. So again, to understand what is a custom runtime, let's dive a bit inside the micro VM where your Lambda code is executing. On one side, you have the AWS Lambda service. there. On the other side, you have your code, the handler code, the code that is invoked when there is an event triggering your Lambda function. So we need something in between the Lambda service and the handler code. And that thing is a runtime. So most of the runtimes are managed by AWS, like Python, JavaScript, and others. And the runtime is quite simple, at least on the paper, quite simple piece of code. It's an infinite loop that will be started whenever the micro VM is starting. And that infinite loop will fetch event from the AWS Lambda service. It's a REST API saying, hey, give me the next event. If there is nothing, the call is blocking and waiting for an event. And if there is something, it returns the call. It returns the event, invoke your custom code, the handler code, take the response back, and post the response back to the Lambda service. So it's an infinite loop that does two things. Get events from the Lambda service, invoke your code, take the response from your code, and send it back to the Lambda service. And the unit of deployment for that might be a Docker image. So we use the format of disk image from Docker as a unit of deployment to Lambda, or a zip file that contains that Bootstrap application and your handler code. The good news is that a couple of years ago, AWS Lambda added the possibility to create your custom Bootstrap. So you're not obliged to use one of the managed environment provided by AWS. You can write your own code. And I wrote a Bootstrap in Bash shell script. Why not? I can call a URL, I can invoke code. We have customers that have written a Bootstrap in PHP, so you can run PHP code inside a Lambda function. And this morning over coffee, someone asked me about COBOL, and guess what? Yes, there is a Bootstrap in COBOL. So as long as you can compile for Linux, because the micro VM is running Linux, you can write any type of code inside your Lambda function, including Swift. So all you need to do, easy, is to write a small Swift application that will fetch event from the Lambda service, call custom code, and post back the result. Good news, someone did that for you already, and it's the Swift AWS Lambda runtime that has been initiated by Apple like 6 years ago by Tom, which is not here today, and Fabian, which is one of the main contributors on this project, but there are close to 40 community members that contribute code to that project as well. So let's see how to write your first Lambda function with Swift. Like usual, when you're starting with Swift, you start with a Swift package init ---- type executable, and you create an executable application. Because remember, inside the micro VM from Lambda, it's an executable CLI that will actually start and provide the infinite loop. So far, nothing really complicated. Then you add a couple of dependencies, and there are one main dependency. It's called the Swift AWS Lambda runtime. So that's providing the loop, the infinite loop, and the interaction with the Lambda service. And we have also a library called Swift AWS Lambda events that provide data structure for all the JSON event types that you might receive from other AWS services. So for example, if it's an API gateway calling your Lambda function, we have an API gateway request and response data structure there. And we have data structure for Amazon Bedrock, the GenAI API, for S3, for SQS, for many different AWS services. So you add the dependencies, and then you write your code. So this code sample is based on a new version of the Lambda runtime that we are currently working on. We call it version 2. It's a work in progress. There is no documentation yet. We're working on that for the next couple of weeks and months. So if you already use the Lambda runtime, it will look a bit different. If you never use the Lambda runtime and you want to start, that's the future. That's the way to go. You import the AWS Lambda runtime. You create a runtime object. I'll detail that in a second. And then you call runtime.run. Notice the .run part, and remember the talk from France yesterday. So this new runtimes is Swift 6 friendly. It integrates with managed concurrency, with service lifecycle, and has a couple of advantages over the 1.0 runtime. So the runtime, basically in the most simple form, there are other ways, but in the most simple form, you just provide a function that takes, remember my Python code? It's roughly the same. It takes an event as an input. In this case, it's an API gateway request. It receives a context, and it produces a response, which is an API gateway response. The API gateway request and response are provided by the Lambda events library. And then in between these two lines, it's up to you. It's your business logic. You might invoke other AWS service. You can use disk. You can make API calls. That really depends on you. My very simple echo demo, it takes just all the HTTP header it receives. It encodes that as a response and gives the response back. So I need to create a zip file with a binary to deploy on Lambda. Remember I said that micro VMs are running on Amazon Linux. So if I compile that code on my Mac, I will have a macOS executable that will fail to start on Lambda. So I need a way to create a Linux executable. And there is a plugin for that, the Archiver Swift Package Manager plugin. So you just type Swift Package Archive. You need to disable the sandbox because it uses Docker internally to create a Linux environment and to compile within Linux. And the communication between the Docker command line and the Docker runtime goes through a socket. So currently we need to disable the sandbox. I was talking with Yuan yesterday that says that maybe there is an easier way to just authorize communication for the Docker plugin. I will look at the Docker runtime, sorry, and I will look at that very soon. So one command, Swift package archive, that will create a Docker container with the Swift runtime for Amazon Linux. It will compile your code, create a binary, and then it will take that binary, create a zip file, ready to deploy on Lambda. Easy. But then you need to deploy the zip file. And remember, most of the time, you don't deploy just a Lambda function. You also need the API gateway or other piece of infrastructure. So one way is to use the command line, one way is to use SAM. And then I was thinking about how to make it easy for a Lambda developer that do not know much about AWS and AWS infrastructure to actually deploy their code. And I thought about creating a new SPM plugin, like a deployer plugin that can invoke SAM for you and generate the SAM deployment descriptor for you. So there are two plugins. One is developed by Apple and Tom, and one that I'm working on, actually on a separate project, called the Lambda Deployer. And I would like to encourage you, if you're versed into Swift on Lambda, to give it a try, or to contribute to the project, or to give me feedback at least on how to make it better. The idea to use it is the same, Swift package deploy. It will generate a SAM deployment descriptor, validate it, and deploy your Lambda function. So only one command to archive, to create a zip file, and one command to deploy. But you want to deploy more than your Lambda function. You need an API gateway. You might need an S3 bucket to store and upload image. You might need a database, for example. So most of the time, you need more than Lambda. So how can you express the infrastructure that you need if you're a Swift developer? Maybe you don't want to learn the YAML file from SAM. So we were thinking about adding a DSL, a domain-specific language, in Swift to describe your deployment. So I built something based on a Swift builder to create a deployment descriptor using the Swift syntax. So you import the AWS Lambda deployment descriptor. You create a deployment descriptor. You add a description because it's mandatory in a SAM template. Then you create a couple of resources. In this case, I want to create a function. I give my function a name, and I give a list of event source, so the events that can trigger that. In this case, it's an HTTP API that reacts on the get HTTP verb on /test. And that's basically all you need. You can add also environment variables and other resources. And behind the scene, the plugin will actually generate a SAM template. So if you run a Swift package deploy, it will search for that deploy.swift file, will compile it, and will generate the SAM template in YAML. That's the first step. Then it will invoke SAM to actually deploy that infrastructure for you. So it simplifies a lot the creation of the template and the deployment of the template. You can stay within your Swift ecosystem, write Swift code to describe your infrastructure, and write or use a Swift command to actually deploy your infrastructure. One of the things I really like with Swift, with SAM, it's the ability to test locally as well. So I can type SAM local testing, and it will create a Docker environment to emulate the Lambda environment. I can pass a JSON file that will be the event that my function will answer. It produces a lot of output, but my print or my console log output from my code is visible there. So it's a very easy and convenient way to debug my code before trying to deploy. So we have a lot of plans on the DSL part. I was fortunate enough to have the help of a trainee of an internship during the Google Summer of Code project. So we now have code to generate the SAM template based on the SAM JSON definition. So we have code to take the SAM JSON definition and generates all the Swift structure for us automatically. We still need to interface the DSL, the Swift builder code, with that automatically generated code. Then I would like to get your feedback on that project and maybe integrate that project into the main runtime. And on the runtime side, we need to land the Swift runtime v2. We need to write doc. We need to write tutorials. I would like all the examples to have user authentication by default, because the examples we have right now are unauthenticated. The example I show you deploy a REST API without any type of authentication, which is not a good practice. I would like to have more use case-based example, and thank you, Michaela, if you are here for your talk yesterday, because it was an eye-opener for me. I would like to have examples like saying, hey, how do we upload and download a file from S3? How do we connect to a Postgres database or a MySQL database? I would like to explore as well the library that has been published by Alastair at last, the .dc, about static linking and cross-compiling to avoid using Docker. Maybe we can, from the Mac, directly generate a Linux binary. Maybe that binary can be statically link with the muzzle libc libraries. It will impact the size of the binary. It might impact the cold start of Lambda. These are things I would like to measure formally and collect data and collect input and opinions about that. And because I have a bit of time left, I would like to talk about one more thing. I had a chance to work with a student from Hoogent University in Belgium last year to create a Visual Studio Code extension for that. So you don't need to use the command line to create your Swift project, to create your SAM template, and to deploy all that. You can just use and install the Visual Studio Code AWS Lambda Swift extension. If I have a minute, I will just switch my screen and show it live if it works. You can see that? You can see that. So I opened the AWS Lambda Swift extension, and it connects to a repository of templates. So we do provide on a Git repository a list of different templates. I just give my project a name. I choose a region where I want to deploy that. Let's deploy that on London. The API name is EU West 3. And then I can initialize a project, and I can choose from different types of template, like an API gateway to Lambda, an SQS to Lambda, S3 to Lambda, a scheduler, or OpenAPI to Lambda. And for each template, there is a small graphical representation of the architecture that will be deployed and a quite brief description of what is this template. So I just initialize the code, and if the network goes well, yes, I receive here. Then if I want to build that project, I just click build, and provided that I have Docker installed and running, it starts the Docker procedure for me. So while it's doing that, let's have a look at the code that I download from the repository. There is a package .swift, and there is a SAM template that says, hey, I want to deploy a hello world function exposed as an HTTP API. What else? We have, of course, the Swift code, so a very, very simple hello world type of code. This is still based on the runtime v1. We are going to update that for runtime v2. We have a sample event, so that's the JSON that your function will receive, so that's useful for local testing as well. And we do provide the Docker file and the make file to build everything inside the Docker file. I'm probably not going to go until the end of this demo because the build might take like 3, 4, 5 minutes. But once the build is done, you can test a local invocation. Again, one click, you choose the event.json that you want to pass. Oh, the build finished, great. So I can deploy. And deployed is the same. Demo, what day are we today, 26? To avoid any name collision. So if I want deploy to AWS, of course I need to have an AWS account, access key, secret key configured on my account, but it's going to deploy the project for me. So it creates the zip file already, that was the build, and now it's creating the API gateway, the Lambda, a couple of permissions as well. Once it's deployed, you can test the remote invocation graphically from the Visual Studio Code as well. So it's a very convenient tool to get started because you don't need to write the template by yourself, the SAM template. You don't need to write the skeleton of your Swift application. You can just grab one of our templates and get started very, very easily. So Marwan is not here today. He was planned to be here. But feel free to send me any question. I will forward the questions. This is open source as well. You can see the code on GitHub and contribute to the code. Okay, and that's the typical demo things where there is an error and it cannot deploy. But you get the idea. Oh, it's my fault actually. It don't like the dash in the deployment name. I should not have had the dash. I was too enthusiastic about showing you this. Sorry for that. If you want to get your hands dirty with the AWS runtime, that's the QR code on the left. If you want to have a look at the deploy plugin and the domain-specific language using a Swift builder to build your SAM template, is the QR code on the right. And let's recap about what I talk about. So I start talking about Lambda and how Lambda is serverless. It's scaled down to 0. You only pay for the service that you need. Most of the time, you need to write infrastructure as code to deploy your Lambda function. There are different ways to do that on AWS, but for serverless context, it makes a lot of sense to use SAM, the serverless application model. And with SAM and the Lambda adapter, you can deploy existing web application unmodified to Lambda, but you can also write your Swift native Lambda function. And then I show you two Swift PM plugin, the archive plugin that compiles on Linux and creates a zip file, and the deploy plugin that takes a description of your deployment written in the Swift programming language, generate the SAM templates, and deploy that on Lambda for you. So my question for you, and come to talk with me during the next break, what are you going to build with AWS and Lambda and Swift? I'm happy to follow up with any questions that you have. Not right now because I'm out of time, but of course I'm staying here for the rest of the day. I'm super active on the social networks, LinkedIn and X, Mastodon as well. I forgot to add that one on the slide, but you can contact me over there. If you want to try that by yourself, just scan the QR code. There is 3 questions about this talk, and please answer this question. It helps me to make the talk and the demo and the slide better, so I'm really looking forward your comments and your feedback. And at the end, you should receive a credit voucher that you can apply on your AWS account, and I have enough voucher for everybody in this room. So thank you very much, and see you during the break.